Okay, so we're going to look at some trig functions for angles and triangles today, which is review from geometry. So first off, you're going to have to use some Pythagorean theorem often to figure out some missing sides in your triangles. So a little warm up. If you want to find the third side in this right triangle, you could just plug in the two sides that you know. Make sure you put your hypotenuse on the side of the equation by itself for C. And then just a little bit of algebra, square your sides. Subtract 49 from both sides, and then since that's side b squared, you'll need to take the square root. Square root of 95 doesn't break down because it's like 19 and 5, so square root of 95 it is. Actual definitions of your trig functions. So if you remember like SOHCAHTOA, you're basically taking two side lengths in a right triangle and dividing their lengths. So just make sure you know which sides in your triangle are like opposite and adjacent. So wherever your angle is, directly across from it is your opposite side. Across from your right angle is always your hypotenuse. And then the last side that's kind of touching your angle is going to be your adjacent side. So just make sure you know your definitions for the 6 trig functions. So to start with on this one, we're going to go ahead and find our missing side so we can get the trig function values. So back to that Pythagorean theorem, a squared plus 5 squared equals 7 squared. Just go ahead and square 7 and 25. You'll end up with a equals the square root of 34. Now that you know all of your side lengths in your triangle, you can just go straight to your definitions. I like to label, like in relation to theta, which sides, like my hypotenuse, my opposite, and my adjacent. So sine is your opposite side divided by your hypotenuse. It's your O in SOHCAHTOA. So you'd have 5 over 7. Cosine is just adjacent over hypotenuse, square root of 34 over 7. Tangent is going to be opposite over adjacent, so that'd be 5 over square root of 34. You're going to have to do a little bit of rationalizing. So if you need to get your radical out of your denominator, you could multiply top and bottom of your fraction by square root 34, and you'd end up with 5 square root 34 over 34. For your reciprocal trig functions, like cosecant, secant, and tangent, it's easiest if you just know which ones are the reciprocals of sine, cosine, and tangent, and then you can just flip them. So like to get cosecant, it's just the reciprocal of your sine value, so it'd just be 7 over 5. Cosine and secant, they both like start and end with s and c. Kind of helps me remember their reciprocals. So you could take your cosine values reciprocal to get your secant value. End up having to rationalize a little bit. And then tangent, if you take its reciprocal, you'll get your cotangent value. It's actually easiest if you flip the one before you rationalize, because then you don't have to like rationalize for a second time. So go back to that 5 over square root 34 and take its reciprocal, and you'll be good to go. This one, there's no picture, so one important thing about like drawing your pictures is like usually C is your right angle. It doesn't really matter where you put angles A and B, but when you label your sides, like side A has to be opposite angle A, side C has to be opposite angle C, and side B has to be opposite angle B. So the sides and angles with the same letters have to be placed so that they're opposite one another. After you've drawn your triangle, then it's pretty much back to what we just did. Find your missing side length, and then go for your definitions of your 6 trig functions. On this one, square root of 40 does break down, so go ahead and simplify your radicals. You can make it 2 square root 10. And then I'm going to label, since we're working with angle B, side B is your opposite side, side C is your hypotenuse, and side A would be your adjacent side. Hopefully you remember your definitions from geometry so that this is all kind of just review, but if you don't, the more practice you do, the better you're going to get. So plug in your appropriate side lengths, divide them. It's a little bit messy with the rationalizing on this one. If you take the reciprocal of sine, you're going to have to multiply by square root of 10 over square root of 10. You don't really need the 2. You could if you wanted to, but it's easier just to do the square root of 10. Secant's easy. And then cotangent, a little more rationalizing. Multiply by your square root of 10 again, and you get 3 square root of 10 over 20. Those special triangles are going to show back up for your trig function values of your 30, 60, and 45 degree angles. So make sure you know them, have their side lengths memorized. You can use them for like sine of 30. So go opposite side for your 30 degree angle is 1, hypotenuse is 2. So you just have sine of 30 is 1/2. If you're going tangent of 45, opposite of either of your 45 degree angles, either one of them would work. Still going to get you 1 over 1 is just 1. If you're back to 30 degrees for secant, that'd be your hypotenuse over your adjacent side. So hypotenuse is 2, adjacent to 30 is square root of 3. So you'll end up with 2 square root of 3 over 3. Main thing is making sure you use the appropriate like adjacent opposite sides for whatever angle it is you're using in your triangle. So if you switch to 60 degrees for your angle, realize that opposite of 60 is square root 3 and adjacent to it is 1. So your opposite and adjacent sides are different than for 30 degrees. So you're going to get 1/2.